When using scientific notation in significant digits, you may think there's some special rules, but they're not. Remember, scientific notation is just expressing numbers in a compact way. So there's no special rules. All we're doing is just combining everything we've learned and putting it into practice. So let's practice. Let's take 2.2 times 10 to the negative 2 grams plus 0.4 times 10 to the negative 1 grams. And we'll divide that by 3.0 times 10 to the negative 2 liters plus 2.0 times 10 to the negative 2 liters. We have to preserve our significant digits while also following order of operations, while also utilizing scientific notation math. So what should be our first step? Well, our first step should be recognizing order of operations. We need to address two addition problems first. The one in the numerator and then the one in the denominator, recognizing that they're both in scientific notation. So, let's do both of those. Let's do the numerator. We know that we have to do it vertically, and we know that the first step in scientific notation math with addition and subtraction is to make sure the exponents are the same. So, let's just stick with the exponent of negative 2. (2.2) times 10 to the negative 2 grams. We need to add that to a number with the same exponent, times 10 to the negative 2 grams. In order to make negative 1 negative 2, that would be making a reduction in value, meaning this decimal point needs to move to the right. So that means we'll be dealing with 0, 4 dot. It's very important that you do not add a 0 after this decimal point. Why do you think that is? Well, hopefully you recognize that if you add a 0 here, that would be creating an additional significant digit that we do not have. That would be turning one significant digit into 2. We must not do that. We have this lined up vertically. If we go to the left, the farthest left significant digit in both of these is going to be the 4. So we're going to draw our horizontal line just to the right of the 4. Since we're adding, our 2 will go here, our decimal will go here, we'll have a 6 here and a 0 here. And this will be times 10 to the negative 2 grams. Let's do our denominator. Again, we want to do vertical addition. We need to recognize our exponents need to be the same. Luckily, our exponents are already the same. so we do not have to change them. We can go straight to lining these up as they are. We have 3.0 plus 2.0, both being times 10 to the negative 2. And these are liters. This makes 5.0 times 10 to the negative 2 liters. Now that our order of operations are complete, we have simplified the expression that we can now use to do our division. Step 2. We'll plug our values in. Recognizing that we did not round this, we need to keep track of our sig figs still. Notice here that I didn't draw a vertical line. The reason being was because if we were to try to draw a vertical line, it would come to the same place value. If I did that, there would be no place to actually round to, meaning both of these are significant. So, we're going to be dividing change back to black, 0.06.2 times 10 to the negative 2 grams, keeping track of our sig figs, divided by 5.0 times 10 to the negative 2 liters. The great thing about scientific notation is that it makes our math slightly easier. All we have to do is divide the front numbers. 6.2 being divided by 5 gives us 1.24. What we should recognize here is that when we're doing scientific notation math and we have exponents and it's division, we're subtracting the bottom exponent from the top. Negative 2 minus negative 2 is just negative 2 plus 2, meaning this is going to be 0. 10 to the 0 equals 1, meaning these cancel out. We're now left with 1.24. We can't forget our units, grams per liter. Now what we can't do is forget our significant digits. Looking here, we drew our line over here. And I technically made a little bit of a mistake because drawing my line over, oops, oh dear, let's correct that. Drawing my line over the 0 was not correct because 0, we should know, is not significant. I really should have only drawn my line over the 6. What we need to make sure we understand is that our answer here should have significant digits that are the least of these two. We know that this bottom number has 1, 2 significant digits, and this top number has only 1 significant digit because this number was only left because we don't round until the very end. So our final answer should have only 1 significant digit. That means our answer, if 1 is what we're rounding, 2 tells us to keep it the same. Our final answer is 1 gram per